Welcome, everyone. I am Caroline Bell, co-director of the National Academy of Sciences, Engineering, and Medicine's Roundtable on Plastics. The Roundtable examines issues related to national efforts to reduce plastic pollution across the plastic life cycle, including interventions around plastic production and waste management, environmental and health impacts, and data collection and modeling. It is my distinct pleasure to welcome you to the fourth of our Perspectives on the Plastic Life Cycle webinar series. The topic of today's webinar is plastic waste management. In this webinar, we will explore the current state of plastic waste management, including an overview of plastic waste management strategies, technical and practical realities that affect plastic waste management outcomes, use of life cycle assessments to evaluate the environmental impacts of alternatives, and the policy and regulatory framework that affect current plastic waste management strategies. Thank you to those who have attended or viewed our first three webinars that focus on what are plastics, plastic design and production, and plastic use and demand. Next slide, please. The recording from these webinars are available on our website. The final webinar in the series will be in March with a focus on plastic pollution. To register for this and future events, watch the event recordings, and stay up to date on Roundtable activities, please navigate to www.nationalacademies.org/ourwork/roundtable on plastics, or use the QR code seen on your screen now. For today's session, we'll be using Slido.com to manage our question and answer sessions. You can access the Slido.com using the widget on the event page, or you can navigate to Slido.com on a separate device and enter the code Plastic Waste Management, or use the QR code seen on your screen now. There will be a Q&A for all panelists starting around 2:45 Eastern Time this afternoon. Feel free to add questions at any time, but please bear in mind that we will likely not have the time to answer all questions live. Then the moderator and panel will have prerogative in topics discussed. I'd also like to highlight that the views and opinions expressed during this webinar are solely those of our experts contributors. Now, I'd like to introduce Jenna Jambeck, a co-chair of the Roundtable on Plastics and distinguished professor in environmental engineering at the University of Georgia. Jenna?
Thanks, Caroline. Hi, everyone. On behalf of my Roundtable co-chair, LaShonda Corley, and I'd like to welcome you to this fourth webinar in our series. We have some excellent speakers today. They're going to share a wide range of perspectives on plastic waste management activities and strategies. I'm thrilled now to welcome and introduce our webinar chair, moderator, and Active Plastics Roundtable member with us, Jennifer Lynch. Jennifer is a biologist at the National Institute of Standards and Technology. So thank you, Jennifer, and I will now pass it over to you.
Thank you, Jenna. It is my honor and privilege to moderate this webinar today, and I am delighted to jump right in to introduce our first speaker on current strategies for plastic waste management, Tim Townsend. Tim is the Jones Edmonds Professor of Environmental Engineering at University of Florida. Tim, thank you for joining us today.
Can you hear me now? Sorry about that. Thank you very much. Tim Townsend, University of Florida. What I want to do today is to provide this group kind of a big picture of where we stand right now in terms of solid waste and, of course, plastics currently, with a major focus on the United States. We can certainly touch upon other areas of the world, but really to set the stage for the boots on the ground perspective of how solid waste and plastic waste are managed, particularly with the perspective of those who are charged with managing this. We're really talking about local governments and the facilities. I want to step back and say, first of all, when we talk about waste, there's a general term that we use in our industry. I'm a solid waste engineer, and we call this universe of material solid waste. But solid waste actually includes a huge universe of different materials. These are all defined under the US federal regulations and of course under state regulations, but only some of that is normally the things that we think about when we're dealing with plastic waste. For example, municipal solid waste, the garbage from our homes and our businesses is of course the source of the PET bottles and the HDPE containers and things like that we'll talk about frequently that get recycled. But there's other sources of plastic in construction demolition debris or in electronics or medical waste. And so we have this large universe of materials, all of these with plastics in them. To kind of frame our discussion though, and I think what really most people think about when they think about the challenge of plastics management is they think about the things associated with municipal solid waste, what we recycle at our home or at a business, at the university, in our office building. So we're going to focus on this material, this universe called municipal solid waste, or MSW. MSW is what you're used to putting in your trash can. It includes what you put into your recycling bin, whether you're talking about paper and cardboard, plastic, of course, but yard trash, all the food scraps and food materials, metal, glass, textile, rubber, leather. You can imagine there's a number of different things. Take a look at the picture though, because one of the challenges we have, it's very easy to draw, and I'll show you plenty of these, a nice pie chart of what's in our waste stream, but garbage is garbage, and it can be a very challenging thing to deal with in terms of trying to recover those materials and resources that we want to recover. I'll share some data with you throughout, and you'll have access to the recording later if you want to spend more time on it. But just big picture, right now, MSW, municipal solid waste, it's estimated roughly 12% of that by mass is made of plastics, okay, or consists of plastics. If we look at the plastic fraction, you can see the different distribution of the resins on the graph on the right, but biggest, you could see low density polyethylene, see high density polyethylene, polypropylene, PET, but these big major sources. This is what's in the waste stream. How do you get those numbers? Well, I would not try to tell you that those are super exact numbers. Those are developed and published every year by the US EPA. There's a pretty big lag though. You can see we're still on 2018 data. It is a fairly complicated approach of trying to track products and how much is wasted in their lifespans. But every year we come up with this estimate of how much waste is out there. Now the states have their own measurements and they'll differ. But big picture, I think it's useful for the discussion that we'll have today. Right now in the United States, roughly half of our waste is landfilled, but you can see 23.6%, roughly a quarter of our waste stream being recycled. That's a respectable number. Certainly we'd like it to be better, but it's not a bad number. 292 million tons of MSW generated per this methodology. Now, if you look though at that 24% recycled on the left for MSW, and then you look at what is estimated for what's recycled out of plastics, what you'll see is that a much smaller fraction of the plastics that are currently estimated to be in our waste stream, again, our MSW, is recycled than the overall material. What does that suggest? Well, that suggests that the recycling rate of many of those plastic commodities and resins that we talked about before is not particularly great when compared to other components of the waste stream. Another way to look at this, imagine that we have the 200 and roughly 300 million tons of MSW. If you can see the green bar at the bottom, that kind of represents how much is plastic. And you can see the fraction going into landfills. Of course, some is going to go to our waste to energy facility or our combustion facilities. And then a certain amount is recycled. But again, if you look up top, you can see the fraction that is recycled of all the wastes and the materials in the US, again, for MSW, is relatively small. Now let's unpack that a little bit more. You can see the recycled plastic here. The way EPA tracks this is they talk about different types of plastic, because again, they're using a model where they look at products and packaging that are produced and what their lifespan is. Certain things we'll call durable goods. These are goods or products that we intend to use and have around for a longer period of time, something that you're not going to throw away right away. And then you have non-durable goods that might be made of plastic that you will throw away relatively routinely. But the biggest fraction of the materials that are recycled, and these are the ones that end up in the curbside recycling bin or in a lot of our set-aside recycling containers, are typically containers and packaging. And again, you can see all the familiar resins, the PET and the HDPE, polypropylene, polyethylene. That's the material currently tracked in terms of being recycled. One thing to notice there is liquid polypropylene, a relatively small amount, but if we were to go back and look, for example, at the amount of polypropylene that's in the plastic stream, it's much larger. So there's some components that are recycled much more than other components. And those will be the kinds of topics I think that we'll see addressed as we go through. Wanted to step back then and let's trace the flow of garbage. Now, again, most of you probably know most of this already, given that we all produce garbage, we all throw it away, but typically if we live in a single family home, we'll take it to the curb. If we live in an apartment or a condo, we'll have a separate room where we can take this to. But normally these days, in most places, we separate our garbage from our recyclables. In a few parts of the country, we may also separate yard trash or food waste or other types of materials. But really, we go out and we collect separately things that we're going to dispose of in a landfill or an incinerator, and things that we're going to try to process in this thing we'll call a materials recovery facility. So that was a garbage truck. There are separate, though, types of trucks that will come around and collect our recyclables, including our plastics. There are two types of systems. There's the single stream system. I would imagine most of you have this right now. It's where you have a single bin. You put all your recyclables in there, including your paper and your plastic and your glass and your cans. But there's also dual stream systems. That photograph in the upper left is from my house, for example, and I have two bins. And so I put my containers and my plastics on one side, and then my paper and other things on the other side. So the type of system that you have that a local government will adopt, and this has an impact on how much recyclable is collected and then their cleanliness. That's something that will depend on the type of system used. In a lot of cases, your garbage gets to a central spot and you put it in from small trucks into big trucks. We call that a transfer station. And then, as we saw before, like it or not, the bulk of our MSW in the United States is currently landfilled. Now, landfills are very strictly regulated. They have, ironically, plastic liners on the bottom of these facilities to be able to contain the liquids and the pollutants that might be coming out. We're required to extract at least a good fraction of the gas that comes out. The plastics that end up in this landfill, what happens to it? Well, for the most part, they stay in the landfill and they don't really change all that much over time. There's a little bit of work out there about microplastics maybe escaping through leachate, but really most of the plastics go in the landfill, they stay in the landfill. Now, incinerators, waste to energy facilities, they take garbage and they combust it. And of course, plastic is one of the things that has a higher BTU value compared to other components of the waste stream. So what happens to plastic in these waste to energy facilities? For the most part, they're oxidized, they go away. Now, does that mean there are no emissions with them? Well, it depends. You have air pollution control systems, and then you have an ash that's left over. But the plastics, for the most part, as a mass, when they go into a facility like this, are going to be destroyed. In terms of composting, normally you wouldn't send plastics to a compost operation. Certainly, they're there as contaminants. There are biodegradable plastics, which is an issue and sometimes a problem when we talk about other types of recycling facilities. But for the most part, EPA doesn't project that very much plastic ends up in one of those facilities. So where does all the material that we talk about here today really end up going? It goes to these things called a MRF. A MRF is a materials recovery facility or materials recycling facility, depending on where you're at. These are not really recycling facilities, though. These are separation facilities. The idea is that we've collected in a truck our recyclables, we send them somewhere to become separated. And again, depending on whether you have two containers or one container, will dictate how it's designed. This is a bit of a panorama of a single stream recycling facility, but the idea is you have these mixed materials coming in, and you might use magnets and eddy current separators, and you use hand sorting and you use screens. And these days you're starting to use more automation, and you'll see optical sorters or even robotic sorting. And so the technology is developing. I'm going to show you just something which is what a lot of facilities look like, though, and that's a simple sorting line at a dual stream recycling operation. You have containers coming across, and for plastics, for the most part, it's simply somebody recognizing the type of resin they're supposed to remove and putting it into the appropriate bin. So again, just kind of imagine that's the challenge you have at these facilities, is how do you take all that material and separate it? These MRFs, they're again separation facilities. Then the MRF, of course, what they want to do is they don't want to throw that stuff away. Obviously, there is certainly contamination, which is a big issue in the industries in these days. But the idea is you take the materials, they're commodities, and you bale them up. Now, what goes into these facilities? We looked at some of the different types of plastics recycled as reported by EPA. Here's one of the big challenges, and I think this is probably a good discussion topic for a group like today, is the fact that you go from one county to the other county to a city to another city, and you get very different rules for what you're allowed to put into the bin. This is an example. This is Sarasota County, and you can see kitchen for the plastics, kitchen, laundry, bath bottles, and containers. Go to a couple other facilities, and you'll see plastic bottles and containers, lids on, 2 gallons or less. Here's a good one. This was I believe this one from down in South Florida, Miami-Dade County, and they give you a very detailed list of what can be recycled, what can't be recycled. And so I'll just show you on the left what can be for plastic bottles, milk, water, detergent, soda, and shampoo bottles. And then they give plastic tubs and jugs, plastic tubs such as the butter and the yogurt tubs, plastic jugs such as milk or detergent jugs. But then what can't be recycled? Here's a lot of the challenge. Plastic bags. Not supposed to put those plastic bags typically in your curbside cart. Creates a huge problem, not only because you got to rip those open, but they get all caught up in the system and they bind and you have to do more maintenance. And then for this county, which is pretty common, you're not supposed to put the cups, utensils, plates, the polystyrene, the egg cartons, the plastic hangers, and things like that. Now, one thing I do, maybe to my neighbor's regret, is I'll stop and I'll take pictures of their recycling bin. This is a few shots of the challenges that you face in the industry right now. So you can see what in the upper left, all that polystyrene. All that's going to do is go to the MRF and it's going to be garbage. It's going to be thrown away and removed. Okay. That hose right there is not going to be recycled. Okay. Lower left, you see those, I guess we call them a durable good, like lids and containers and laundry baskets and things like that. Not going to get recycled. These are all people have meaning, good desires. They want to do it. And it's plastic. So why can't I put it in the bin? But they're simply not taking those things at those facilities. And then this one right here, this is from a single stream cart, but you can see what plastic gloves and bags and looks like some kind of toy or something like that. So the huge challenge the industry faces right now, and this is, I think, one of the big things that has to be addressed if you really want to get curbside residential recycling better, is how do you educate? And I'll just make the point, sometimes I'm a little skeptical of my students, but even with the greatest education program in the world, sometimes it just doesn't work, and that people just will not put the right thing in the right bin. This is actually, I took this photo at my mom's apartment complex not long ago. That's a single stream bin. The sign is right above it, yet everything in that bin underneath it is still, not everything, but much of it isn't supposed to be there. The one on the top, you can see clearly labeled recycling and landfill, but I still see a bunch of PET bottles inside that landfill bin. That's a bunch of university students too. And then my daughter sent this the other day, that one on the bottom right, but I don't know that you could get a much more confusing bin than that one right there. Now, there are opportunities to be able to recycle this material that don't get taken in there. I can go to my grocery store and take my egg cartons and my plastic film, for example. Or if I was in California, I could go to this vending machine and get my deposit back if it was a deposit state that you could do that in. But the idea, though, I want to kind of end on is, this is the challenge that you see at these facilities that accept all these different kinds of plastics. Well, not just plastics, but other materials. So the question is what are they going to take? This is a real quick shot of the current recovered commodity prices for different materials that are typical waste streams in the US. And you can see, I was amazed, but if you look, this is in dollars per ton. But right now, natural HDPE is valuable as aluminum. Aluminum has always been the big gold standard for what's most valuable. But start looking at the other materials, PET, polypropylene, but then you start going down the list and there becomes a lot of things that are not particularly that valuable. Now that's just the individual components. What we do is we track, or I say we, the industry tracks what we call a blended value of the commodities, the mix by how much is there in its value. And so that red line, look at it, about $120 a ton. So that's the separated material. So $120 per ton, you might think, okay, well, that kind of makes sense. I can see why recycling works, because a landfill might be $50, $60 a ton. But when you do, this is my real simple recycling economics 101, is that what you find is that if the recycling cost is equal to cost to collect, cost to process, minus the market value you can get back, minus what you save from landfill diversion. So the idea is that I just give some example numbers, and of course this depends on where you're at. Lesson is it costs money to recycle. Okay, I think a lot of people don't understand, but local governments do not make money. It costs them more to recycle in most cases than it does to put it to the landfill. I think this is my last slide, but this is from a paper that we did a couple of years ago. And what we tried to do is we tried to see what is the cost, though, of doing it for the average homeowner. And what we found is there was only maybe one time in the last few decades when you saw it break even. It's usually always a cost to local governments to do that. But I would argue the cost is not that great. Even under the worst cases, $50 per year for a home. And I know most of my neighbors probably, if given the choice, would probably say, I'd be willing to pay that much to have that material go to a recycling facility. Now, the other thing that's in there we're not going to get into right now is that there are benefits, though. And so one of the challenges this group and others need to talk about is how do you convince the public and the stakeholders of the benefits? Because if you look at the cost you pay for that recycling, what you find is the environmental benefit you get is oftentimes much better than these other programs, including switching to EVs and hybrids and even solar power in some cases. So there's a definite benefit to doing it. But a lot of local governments have begun to try to switch off their recycling programs because of the cost. And so I know I went maybe a little over there, but I just wanted to, I'll end this here, and then I'm happy to answer questions when the time comes. Hopefully you get a better understanding of what garbage is like in the US right now.
Thank you so much, Tim, for that very excellent presentation. I think we do have time for a question. And so I actually have one. The MRFs, they actually are the ones bailing and selling and shipping this stuff away from municipalities. I'm curious if the municipalities tell the MRF what to recycle, or if the MRF tells the municipalities what they will recycle.
That's a good question. So first of all, sometimes the municipality owns the MRF. So in that case, the question's answered. They'll do whatever they decide they do. In other cases, a MRF will they'll take certain things, but normally since they're getting paid, they'll take whatever the local government decides they're going to send them. Now, if they send them something where they take lots and lots of materials in, they might charge them more to process it, though. The MRF is normally their business. They're going to separate, and then they're going to try to market that. And if they end up getting a really clean recyclable stream because a certain local government only accepts certain things, they might give them a better rate than one that accepts everything in the world where they have to separate out more and then throw it away.
Interesting. Well, thank you so much. We're going to move on. I am now excited to introduce our next speaker, Scott Trenor. Scott is the Technical Director at the Association of Plastic Recyclers. Scott will speak about some of the technical and practical realities that affect plastic waste management. Scott, thank you so much for joining us. I don't believe we're hearing you, Scott.
How about now?
Yes.
All right, sorry about that. So thanks for the introduction, Jen, and thank you to the National Academies for having us. So what I was hoping to do in the next 10, 15 minutes or so is give you a little bit of idea about who APR is, what we do, and then talk about some of the realities of the reclaiming of plastic. So taking those bales that Professor Townsend talked about that the MRFs create and making those into usable products. So a little bit to start, who is APR? We're a US-based international nonprofit. We're the only North American organization based, focused solely on recycling of plastics. Our mission is relatively simple to state, but much more complex to do, right? So to recycle more plastics, to reduce, and our tagline is waste, but really by recycling, we reduce litter, we reduce landfilling, we reduce extraction of non-renewable resources. And as I think we'll learn from the next conversation with Taylor, using recycled plastics reduces greenhouse gas footprints of the products that we make and use every day. So APR is made up of members. We have a little over 300 members. Our core members are the recyclers and the reclaimers and the MRFs. So like waste management, we saw a waste management truck in the last presentation. So somebody who hauls from your house, collects and sorts. And then the reclaimers who take that sorted material and make it back into film like a Circulus does, or make it into paint cans like KW Plastics, or back into PET water bottles like the Custom Polymers do. Then the rest of our memberships, so we call affiliates, that's everyone else in the value chain. And we use all this combined expertise to develop guidance in package design and policy to aid the recycling system. So we have 4 primary goals. The first is to increase the supply. Second is to enhance the quality, right? If we have a lot of supply but a poor quality, the application space is quite limited. Expand demand for the use of recycled plastics and communicating value. One topic I won't spend a whole lot of time on is that we have a very strong policy arm, and Kate Bailey, our policy director, actually spoke at the last webinar in December. So we are active at essentially all levels of government, from local up to the UN Plastic Waste Treaty. And we really support 4 key programs. So the first is extended producer responsibility for packaging to ensure that we have adequate funding for those MRFs, for those sorting facilities. We support bottle deposits because it's proven that when there's a bottle deposit, or I think the going term now is recycling refund, that people recycle more and they value that refund. Ensuring that recycled content gets used back into packaging and other durable goods and applications, and then design. So when we think about, whether my package is recyclable, and Professor Townsend kind of showed those very confusing signs, right? We mostly focus on business to business. And in order for a brand to say that their packaging is recyclable, they need to meet 4 criteria that are set out by the Federal Trade Commission Green Guides. The first is where we are very strong in, right? So that's designed for recyclability, to ensure that that package can make it through the sorting, can make it through a reclaimer, and can produce a usable recycled material. The second is consumer access to recycling. So if you don't have access to recycling, right, you clearly cannot recycle. There's nowhere to put your recyclables other than in the trash can. Then that package needs to be accepted in the recycling stream, and we saw examples of how different communities and municipalities shared what is acceptable in the last presentation. And then finally, there has to be an end market. So in the first presentation, we learned quite a bit, or we saw quite a bit about this first pass part of the multi-step value chain, right? So the collection, the trucking, the sortation into these nice neat bales. And what I'll focus on for the rest of the talk here is this second half. So where these bales are typically trucked over to a reclaimer. This is, I think it's a natural high density bale. The reclaimer is what we call the entity that takes these bales, processes that into pellets that can be used to make other products. So in terms of the kind of state of the art, and Professor Townsend showed some numbers from the EPA, these are numbers from that we generated or that were published in this STINA report. And it's based on purchasing and sales orders for the reclaimers that are our members. In the US, we recycled, and this is for 2022, about 2.2 million metric tons of PET bottles, high density bottles, polypropylene film, and then other plastics in 2022. I think on one of the charts, we saw the China sword, and we all heard about how we ship our plastics elsewhere to be recycled. Currently in 2022, if you look at the materials that we collect the most of, over 86% of that is recycled here in North America. So we're no longer really shipping our plastic waste across borders. Well, we're shipping it across to Canada and Mexico because we do share supply chains, but not to Asia, much like used to be some of the common case for the West Coast. So that's how much we recycled. We could recycle a whole lot more if we could collect more. So these last 2 charts show the reclaimer capacity. So we collected 860,000 tons of PET in 2022. We had enough capacity to recycle 1.3 million metric tons in 2022. And that's part of the problem, and Professor Townsend mentioned that too, right, is being able to collect enough material to fill up this capacity. So that's approximately 500,000 tons of excess PET recycling capacity ready to be turned on as we collect more material. Thinking about what 2.2 million metric tons is, it's kind of hard to wrap your head around, right? It's about 5.1 billion pounds or 225 shipping containers a day. If we use EPA's WARM model, that's the equivalent of taking about 500,000 cars off the roads in the US per year. So significant greenhouse gas savings. So where does this happen? Plastics recyclers are all around us. Maybe not so much if you live in the middle of the United States, but this is a map from the EPA showing the 175 plastics reclaimers that are across the US. You know, from KW Plastics down here in South Alabama, all the way up to Orpet and Denton up in Washington State and Oregon. This circle is about 13 reclaimers to give you an idea of what's going on in Southern California. So when we collect, we essentially ship locally. As you could tell, these are mostly around either population centers or areas where there's a significant amount of manufacturing. So what do our recycled plastics become? Well, it depends what they start as. So if we think about PET water, soda bottles, and clamshells, like you might get your strawberries in at the grocery store, 60% of PET water and soda bottles go back into water and soda bottles now, and that's up from 30% just 5 years ago. The next highest application is textiles, so either clothing, apparel, or carpet fibers, and then back into those thermoform clamshells. For the number 2, so high density bottles, tubes, and canisters, the biggest applications are back in the tubes. So whether it's a detergent bottle or a personal care lotion or shampoo bottle, then plastic pipe is the next application. And then there are a number of other applications like home and garden. And then actually waste management requires at least 10% recycled content in all of their trash and recycling carts. So that's a relatively large application for those. The flexible packaging, so these are the things that you take back to the store and the store drop-offs, and Professor Townsend showed the front end of, I believe it's a Publix. And the reason I think it's a Publix is because they're very consistent in their labeling and their locations of those recycling bins right out front of the store. That flexible packaging, the largest 2 applications are right back into film and flexible packaging, and then plastic lumber like a Trex or something like that, and then back into construction and home and garden. And then finally, the number 5, polypropylene. Due to the durability and the wide range of applications for polypropylene, a lot of it doesn't go back into consumer packaging per se, but it goes into automotive applications. So that yogurt or butter container tub that you put in your recycle bin could come back as a car bumper. If you've been to a home improvement store and you've seen kind of those grayish black plastic cans, those are polypropylene, recycled polypropylene. And that has, in that case, you're replacing a steel or metal can with a much lighter weight, lower carbon footprint plastic, recycled plastic can. And then going into, you know, home and garden again, storage totes. But, you know, in all cases, as we think about and we hear words about upcycling and downcycling, really the key is that we're recycling. And in all cases, these recycled plastics, whether they go back into the original application or another, they're displacing virgin plastics and other materials with a lower carbon footprint option. So if we think about PET water bottles, how does it go from that bale of material to back to a water bottle? Well, it goes through a reclaimer. So the reclaimer gets these PET bales. You can see probably on your screen that there's a lot of contamination in here. I mean, right here's I think a Pepsi can. So these need to be sorted and reprocessed, and then they end up as flake here. And in order to do that, they go through a number of unit operations. So that bale comes in. This is all mostly all automated. So they'll break that bale. They'll use magnets to get rid of the baling wire and other metal. They'll have manual sorters up in the front, getting rid of things that's going to affect the equipment. So kind of like the hoses and bowling balls and other junk that shouldn't be in the recycling bin. Then they get sorted by size and shape, and that gets rid of paper, cardboard, sand, glass. They blow air through it to, again, get rid of more sand and glass and other small things. It'll run through an eddy current detector to pull out aluminum cans. And then it'll go through a set of automatic sorting system, and this is near IR sortation, optical sorters, as Professor Townsend called them. Typically in a PET recycler, each bottle will go through 5 different sorters before it ends up in the residual line, and that pulls out other polymers and metals. It might go through a delabeler at this point in a whole body wash. Then it'll go through more optical sorting and also color sorting to really keep the clear PET only. Another set of manual sorting in case something's missed, and then it'll be ground into that flake. So then the next set of steps takes that flake, and you can see labels and other things here, and turns it into something that you can then make a bottle out of. And the unit operations there are shown here at a high level. So first it's washed with sodium hydroxide at about 85 degrees C to remove, residual soda, other liquids, peanut butter, for instance. Then it'll go through a float sink tank, and that's where the plastic caps, which are a different material, are very efficiently removed and then sold to another recycler. Those will get rinsed, dried. We'll go through another eddy current and a metal detector to remove residual aluminum and steel. It'll go through an elutrate to get rid of little small particles that might clog systems. And then it'll go through a flake sorter. So much like we use optical sorters to sort whole packages, this will sort those individual flakes for color and other materials. Excuse me. So all of these unit operations, much like we saw in the previous presentation with sorting, cost something. So why are recycled plastics considered expensive? And what's the cost of contamination? So if we think about going back from a bottle to bottle, right? That PET curbside bale is about $300 a ton, $330. The yield of clear PET flake from that is about 55%. So your effective cost is $600 a ton. Those first 2 slides cost about $25 a pound to run through. So now we're at $1,100 a ton. If it goes back into a soda bottle or a water bottle, it needs to be thermally processed to get back into a pellet, and also solid stated to improve properties and devolatilize and remove contaminants. That's maybe 5 cents a pound. So we're talking about a material from just cost of material and processing that's $1,200 a pound. We need to add in margin and overhead, right? We need to pay the employees there. So 55% of that goes back into bottle. We have 17% of that bale that goes into other recycle streams. So that's the colored PET, aluminum, fines, and then those caps. And then we have the contamination. So when we buy a bale, we are essentially buying contamination. So in this case, about 28% of that bale is contamination. So we're paying $92 for that contamination. We have to remove it via processing. I'm assuming about 50% of the process cost. And then we have to landfill it. So the US average landfill fee is $60 a ton. So that 28% contamination is costing the system $360 a ton. So if I think about processing and raw material costs and contamination, recycled plastics and PET in this case comes out to about $1,560 a ton. Virgin bottle grade PET is about $1,200 a ton, right? It's a completely different supply chain. It's much more efficient. It's a system that's oversupplied, so margins are tight, if at all. So what can we do to support this recycling system? So depending on where you are in the supply chain, right, or if you're just sitting at your home, buy recycled materials or products with recycled content. So I'm not a big water snob, I will say, and to be perfectly honest, I usually use refillable water bottles, but if I need to buy a bottle of water at the store, I buy one that's in a recycled plastic container. Support policies that aid in circularity, as I mentioned, as I described before. Buy and design products with recycling in mind. If you are choosing between 2 products on the shelf and one container is recyclable or accepted in your recycling system and the other one is not, buy the recyclable one. And then recycle right. So learn what's accepted in your local collection system and only put in the bin what they accept. Flexible packaging needs to go back to the stores. Leave your caps on. And empty packaging to reduce contamination. I'm not saying, wash out your peanut butter jars, but, make sure they're mostly empty. So with that, thanks everyone for your time. Couple QR codes here to match the previous presentation. So our podcast recycled content, you can reach that here. Our design guide for plastics recyclability is here. And then a description of how recycling works, which is mostly a combination of the first two presentations you saw today is here. So thank you again, and happy to take questions if we have time.
Thank you so much, Scott. That was very informative. I think we don't have time for questions between the next talks. I want to remind the audience that we are taking questions through the Slido app. You can go to slido.com and enter hashtag plastic waste management to join the conversation. I've been watching some of the questions come in, and I think it's great to see, Scott, your opening eyes and going, wow, I didn't even know we recycle 2 4s and 5s. Very informative for the community. Thank you. We're going to come back to all those questions as the full group together at the end. Now I would like to introduce Taylor Uekert, our next speaker. Taylor is a circular economy and operations research analyst at the National Renewable Energy Research Laboratory. Taylor will speak about the use of life cycle assessments to evaluate the environmental impacts of alternatives. Welcome, Taylor.
Sorry, having the same issue as everyone else of forgetting to unmute before I share my screen, but here we are. Awesome. Well, I'm so happy to be here today, and thanks everyone for joining. And as you saw some of the pictures in the previous presentations, you might have had some gut reactions. Maybe you saw some of the clean flake that Scott was showing. I was like, oh, that seems good. Or you saw some of the overflowing bins from Tim's talk and we're like, oh, that seems bad. And I think waste can invoke a lot of these feelings because it has that ick factor, that U factor, right? But what I'm hoping to talk about today is how we can turn those gut reactions into actual understanding of the environmental impacts of these different plastic waste management strategies. And one way that we can start to quantify these feelings into actual numbers is through a technique called life cycle assessment, or LCA. Some of you may already be familiar with this. It's becoming increasingly common in industry and policy regulations. But for those of you who are not familiar, an LCA is essentially just an analysis of the impact that an object or a process has on the world around it. And this is standardized. There's the ISO 14040 series that gives a lot of details on how to do this type of analysis, but it comes down to 4 main steps. So first, you have to figure out what is your scope and your goal. So what are you evaluating and why? For the sake of this presentation, what I'm trying to evaluate is the environmental impacts of different plastic waste management strategies and how they compare to one another. Once you've decided on that, you then go into building something called a life cycle inventory. And this is just the material and energy inputs and outputs of the process or processes that you're evaluating. In some cases, this could come from direct measurements. So say you're a company, you have the ability to measure all of the inputs and outputs of a system. In other cases, this might be based on modeling. So for example, at NREL, we do a lot of Aspen modeling for new technologies, and we estimate the material and energy flows from those models. So once you have that list, you then have to connect it to what we call background data, which is basically these huge data sets of information on how these different materials and energy are created. So say we know in my recycling process, I'm using electricity. We need to know what are the impacts of that electricity, right? And so databases such as EcoInvent or USLCI tell us here are the impacts associated with producing electricity in this particular region. So you've pulled all this data together, you've put it in some sort of LCA software, and now you're going to do the actual impact assessment, which is when you link all of these different material and energy flows to these known environmental impacts, And you essentially do multiplication, addition, and you end up with an overall number for a given metric. And I just want to say that LCA is often associated with greenhouse gas emissions, carbon footprinting, but LCA can tell you a lot more. It can give you information about particulate matter formation. So how clean is the air that we're breathing? Or it can tell you about ecotoxicity. So how are the organisms in my natural environment being affected by toxic releases? So there's a lot of different information that you can get from LCA beyond just greenhouse gas emissions, although that will be what I mostly focus on today for the sake of this presentation. And then finally, in step 4, you do your interpretation. So you look at all of these results and you think about, how can these results inform my goal? How can they inform decision making? Again, going back to my goal of discussing different options for end of life, how can LCA help me pick what might be the least impactful option of these different plastic management strategies? And so you're probably thinking, Taylor, this is not rocket science, seems pretty straightforward, but I just want to say that there are a lot of limitations when it comes to LCA. This is not necessarily an exact science. So first off, any analysis is only going to be as good as its data. If you're missing information on the materials that's being used in a process or how the electricity is being generated, that's going to affect your results. Second, and this is really important when we think about waste management, systems that generate different products are really difficult to compare. If you think about landfilling versus incineration, landfilling is kind of on a mass basis, right? How much material we're throwing away. But incineration, you have this extra factor of you're producing energy. So are you comparing based on weight or are you comparing based on energy? And this leads to my final point, which is that assumptions are honestly a crucial part of LCA. There's assumptions throughout each of these steps. And depending on, which metrics you're looking at, which data you're using, which types of products you're considering, you're going to end up with different results. And that means that not all LCAs are directly comparable, and I'd suggest you treat them more in terms of trends rather than exact numbers. So all that being said, hopefully we're kind of all on the same page on LCA and what it can tell you. I'm now going to briefly go through the different plastic waste management strategies that the previous speakers have so kindly introduced for me and talk a little bit about their overall impacts. So if we start from landfill, we know that right now this is the primary mode of disposing of plastic in the United States. And as Tim mentioned, something that's interesting about plastics is it's very durable, right? And this is in contrast to things like food waste or yard waste that also end up in landfills. So once plastic itself is in a landfill, it's pretty much just staying there. It's not degrading like a food waste component would. It's not emitting much in terms of greenhouse gas emissions or methane. And that means that the overall greenhouse gas emissions, which is on the rightmost figure in the orange, are relatively low for landfilling of plastic. You can see they're much lower than plastic production. And the variation in these bars is just showing kind of different types of plastic is the range that these figures are showing. We also know that landfilling is cheap in the US. One thing we are lucky to have is a lot of land, and so tipping fees are relatively low. And so overall, landfill is a pretty inexpensive and a low emissions mode of disposing of plastic. That being said, I want to just mention that there are a lot of trade-offs. Number one, by landfilling, we do have to produce more virgin plastic, right? Because we're losing that material. And that means we're going to have to deal with all of the costs and the emissions associated with these plastic production bars in these figures. Second, this doesn't account for kind of community impacts. I remember I lived briefly in Arizona when I was younger, and when my parents would be driving me to gymnastics practice, there was this stretch that went past a landfill, and I distinctly remember seeing how long I could hold my breath as we were driving past this landfill, especially in the hot Arizona summer. So there's these other things like how the landfills are affecting communities, whether that is scent, whether that's other impacts that also need to be considered. Next up is incineration. So again, this was introduced in the first presentation, but essentially with incineration, you're combusting all your plastic, and the carbon in that plastic is mostly released as carbon dioxide. So you have a lot of CO2 emissions coming from plastic incineration, but you are also releasing a lot of energy, and that energy can be used to drive turbines, which generate electricity. And this brings in something about LCA that's always a little bit tricky, which is how do you handle co-production? So you can see in this little schematic in the middle of this slide that I have this green bar for electricity. And essentially what that is saying is that by incinerating plastic, we are no longer having to produce a certain amount of electricity from natural gas or coal, which are the predominant modes in the US. And so that kind of levels out your overall impacts a little bit. But you can still see on the right side of this slide that your overall emissions from incineration are kind of on a similar level to virgin plastic production and much higher than what we saw for landfill. Next up is mechanical recycling. I'm so glad Scott gave so much great information on how mechanical recycling works. Essentially, you're just grinding up, cleaning up, and extruding your plastic so that you can produce new plastic products out of it. And overall, kind of the overall costs tend to be lower than virgin plastic production, although that's very, very dependent, as Scott said, on how much your initial starting material from your MRF is. So these are estimates that are on a little bit the lower end of historical trends. This could go up to overlap a little bit with virgin plastic production. But we also see that greenhouse gas emissions are significantly lower than virgin plastic production. Most of these are related to electricity use for kind of shredding, washing, etc. of the plastic. And so overall mechanical recycling is a fairly low cost and impact way to keep plastics in circulation, so you no longer have to be producing as much virgin material. I know the focus of this webinar is kind of on the status quo today, but I also wanted to talk a little bit about emerging plastic waste management options. So with mechanical recycling, as I said, a lot of benefits, but it cannot necessarily handle all types of incoming feedstocks, especially contaminated or mixed feedstocks. And that's where chemical recycling can come in. And what I want to emphasize here is that chemical recycling is not just one technology. It's actually an umbrella term for many types of technology that all break the bonds in plastic to create kind of starting molecules that can then be used to make new chemicals and plastics or to be used as fuels. And the type of kind of bond breaking that is able to be done depends on the type of plastic. And so what I'm showing here is kind of different depolymerization techniques for PET, that's the chemical recycling polyesters, as well as things like pyrolysis for polyolefins or polyethylene and polypropylene. And that's in comparison to their virgin production. And most of the costs and impacts of all of these technologies are related to energy use and chemical use, as well as yield losses associated with each of these technologies. And you can see the cost of these kind of emerging options tends to be on the order of magnitude times higher than conventional production of plastics. But the greenhouse gas emissions vary a lot depending on which technology you're looking at and which type of polymer that you're considering. And these are early stage technologies. Some of them are being upscaled, but a lot of them are still kind of in the lab. So there's a lot of room for improvement here. And again, just emphasizing overall impacts really depend on the exact chemical recycling technology. The last one I wanted to briefly touch on is composting. So composting, industrial composting specifically, is relevant to some types of biodegradable plastics, such as polylactic acid or PLA. You might have seen some drink cups that are labeled PLA. And essentially, with this, you're able to convert that plastic into compost and CO2. Around 20% of the carbon ends up as compost, and about 80% is emitted as CO2. And something to note is that plastics actually don't contain any of the nutrients that are important for compost, like nitrogen or phosphorus. So they're not a particularly desirable kind of material to be bringing into composting facilities. And so composting can help reduce total amount of waste, but similarly to landfilling, it does necessitate the production of more virgin plastic, which, depending on how you account for bio-based content, which is why the range is so big in this particular greenhouse gas emissions chart, it can have higher impacts than composting in the first place. All right, so last thing to discuss is that you might have noticed that there's no perfect end-of-life option. We live in a world of trade-offs, and there's really no silver bullet that meets all of the criteria that we want, right? And so how can we start to handle these trade-offs? And so my team is doing a lot of work on things like optimization modeling, multi-criteria decision analysis, which essentially allows you to choose options across multiple metrics and across multiple pathways. And I'm just showing one example here where we sampled a whole bunch of different plastic end-of-life management strategies for PET specifically, and tried to find kind of the happy medium between low greenhouse gas emissions, low cost, and high circularity. And you can see one potential solution uses a combination of landfilling, mechanical recycling, and chemical recycling. So this is really just emphasizing that there are there's a toolbox of solutions available to us, and we want to make sure we're effectively using them. So to wrap up, I hope you now know about LCA a little bit more and how it can help us estimate and compare the impacts of end-of-life options. Recycling and landfilling actually have the lowest impacts, but there are, of course, trade-offs related to virgin plastic production. And then new end-of-life options like chemical recycling really need to be carefully evaluated and optimized so we can make sure that we're maximizing their benefits rather than causing more harms. And with that, thank you very much.
Taylor, thank you very much. That was very informative and almost exhausting in the complexity of it and having to weigh all of those trade-offs. Thank you for acknowledging all of that. We are going to have to hold questions so that we can get to our final and fourth speaker. I am pleased to introduce her, Kristyn Oldendorf. Kristyn is the Senior Director of Public Policy and Communications at Solid Waste Association of North America. She will talk about policy and regulatory framework that affect current plastic waste management strategies. Welcome, Kristyn.
Thank you. Happy to be here. So just want to share, a little about SWANA. We are the Solid Waste Association of North America. So we're a nonprofit membership association with about 10,000 individual members across North America. And we're kind of unique in that it's a range of public sector, cities, municipalities, as well as private sector. So like the WMs or other companies that, collect materials, as well as nonprofits, universities, and others. And it's kind of across the industry. So collections, landfills, recycling, waste to energy, pretty much everything that was just discussed. So we kind of bring everyone together there. And these are some of our key goals shown here. And I just want to emphasize that we really see the waste and resource management industry as being really valuable and being a really big part of the solution when we talk about plastic pollution. We're kind of, if you think about putting your waste out or your recycling out, you don't really have to think about where that goes because of, the people like those that are our members who are taking care of it every day. So today we'll be talking about policies that support plastic pollution prevention. And my role is really just to provide an overview of these policies. It doesn't mean SWANA is endorsing them. I'm just kind of sharing the policy options. Also, there's a lot of policies out there, way more than I can cover in 15 minutes. So this will be sort of a high level overview, but to give you the sense of, what are the policy options out there? And when we talk about policy, I think it's always important to start with the question, what is this trying to solve? If you just put something in place because you think it sounds like a good idea, but you don't really think about like, well, what are the actual impacts and, how will other things potentially be impacted? You really need to think through all of that. So, volunteer actions are really important. Collaboration is important. Sometimes that only gets us so far. So policy interventions in different ways can help us get to that next step. So you may have seen this before. This is the Ellen MacArthur Foundation, what we call the butterfly diagram. And it's the kind of circular economy system showing how materials flow. So there's lots of different ways we can get to that kind of circular economy. So instead of that, like what we call the take, make, waste model, it's how do we keep materials in circulation? So I circled here recycling to show that this is one piece of the puzzle. It's an important piece. It is one piece. You have to kind of think holistically about everything as we think about solutions. So we had previous speakers show some really great step-by-step of how does recycling work. So keep in mind here, policies can work at any step in the process and need to think about every step in the process, kind of thinking holistically about the system. So the communication, we know there's many different ways to communicate what materials are recyclable. It really depends. So that piece is really important. How convenient is it to recycle? Do you have to drive somewhere to drop off your materials, or can you set it out on the curb? How do collections work? How does that sorting work? How does it get to the remanufacturers? So policies can impact, the kind of, are you required to recycle? Are there incentives to recycle, all the way through, incentives to use that recycled material and, each one of these steps. Okay, so to set the stage with policy, kind of big picture, federal policies lay the groundwork. So the Resource Conservation and Recovery Act, known as RCRA, was signed in 1976, and this is kind of the backbone of waste management in the United States. And it's been amended since then, but it really provides that regulatory guidance on how waste is collected and managed and transported and disposed of. Subtitle D of this act really is looking at the non-hazardous solid waste requirements, which is our focus here. So it's basically laying out the minimum standards, and then it's the states that really play the role in the implementation of those standards. The states are often issuing the permits. So I'll be talking quite a bit about state and local policy actions, but they need to comply with this RCRA federal requirements. And this is important because in countries that, maybe don't have a law like this, or where it's not enforced, that's where you're seeing a lot of lack of proper waste management, where you're seeing a lot of open dumping or things going into rivers or open burning. Those things are not allowed in the United States. It might happen, but it shouldn't be, and there is enforcement of that. So that's why this is really important. I just from personal experience, I did the Peace Corps in Honduras, and that's really where I saw a lot of waste mismanagement and where I really became interested in this topic. So I do see the role of policy of setting those standards and making sure there is enforcement. Okay, so what is the federal government doing specifically around plastic? There have been a few plans released in the last few years. This national recycling strategy was the first part of what the EPA is calling a circular economy series. So thinking back of that kind of circular economy model. So this lays out different strategies for improving recycling markets, increasing collection, reducing contamination. So it's laying out like what are all the different strategies and how do we get to a better recycling rate as a country. More recently, just this past November, the EPA released its national strategy to prevent plastic pollution. So this is really looking specifically at plastic pollution. How do we keep plastic out of the ocean? How do we clean it up from the ocean? How do we improve waste management? And each of these strategies listed has different techniques and strategies under it. So if you're wondering about the progress of these plans, this EPA website has kind of an implementation plan platform where it's showing how funding is going toward these recommendations, federal agency collaboration, and the progress and expansion of existing programs. This chart from the EPA kind of shows what are all the pieces of this, what are the pieces of the puzzle. And on the left here, you can see the solid waste infrastructure for recycling grants is going to fund the objectives within that national recycling strategy. So that we call that SWIFR for short, the Solid Waste Infrastructure Program, since it is a long name. So the SWIFR grant program provides funding for recycling and other efforts. In addition, the Consumer Recycling Education Outreach, or REO grant program, provides grants more so for education. And the Save Our Seas Act actually was signed into law in 2020 and really focused on plastic pollutions, but it was the act that authorized the SWIFR grant program. That's how it got started. But then the funding actually came from the bipartisan infrastructure law. And that law provided $75 million to fund those REO grants, as well as $275 million to fund the SWIFR grants. And that's from not all at once, but it goes kind of year by year from fiscal year 2020 to 26. There's different rounds of funding available. So it does end in 26. So thinking about how policy can give us a more constant stream of funding is something to think about as well. So this map on the left here is actually an interactive map if you go to the EPA website, and it shows what's been implemented, what grants have been given out so far. And this really helps to support recycling infrastructure and communication throughout the US. There's a lot of interesting projects going on that have been funded through these grants. So there is an opportunity, as I mentioned, to kind of expand on this and have a more permanent source of funding. Okay, so other policies, we've talked a bit about EPR, extended producer responsibility. This really has potential to get more funding into the system, as well as potential to have products to be better designed for recycling and to incorporate recycled content. Container deposit return systems, sometimes these are referred to as bottle bills, also provide incentives to recycle. APR talked about these a bit more in depth in the December webinar, so I'd encourage you to check that out to learn more. So requirements to use recycled content are a policy mechanism, and sometimes you see that as part of an EPR bill, sometimes it's standalone. New Jersey, for example, passed a recycled content requirement, but did not pass EPR. So that's an example of it being standalone policy. Labeling requirements are also really important. If you go to the grocery store and look at all the different symbols of recycling, it can be really confusing. And so having standards around, how that recycling symbol is used or what directions are given helps us, kind of limit contamination and make sure materials go to where they're supposed to be going. So other policy drivers include funding mechanisms. All of this does cost money. It's a lot of infrastructure to be collecting and processing recycling. So is your system funded by the general fund? And if it is, then it's competing against things like schools and libraries and roads. Or is it funded by the utility fund, meaning is it self-sustaining and funding itself? Tipping fees, in some parts of the country, it's, relatively cheap to landfill. In other parts of the country, it's much more expensive. So thinking about how much you're charging for materials to be processed through a MRF compared to a landfill has an impact. And then, funding incentives such as tax incentives or grants or low interest loans can help get that infrastructure started. Some states provide technical assistance for local government or for businesses to enhance their recycling programs. So that can also be a policy driver. And requirements to recycle, this sounds pretty straightforward, but probably most places, it's not actually required to recycle. So thinking about, our apartment buildings required to provide recycling for their tenants, our universities and stadiums and special events required to recycle. How is that enforcement handled? And then if there's contamination, how do you keep contamination out of it? So those are all kind of basic things of how do we get everyone on the same page with actually recycling. Bans on items are also, a mechanism many states and local governments have implemented. Some common bans include plastic bag, polystyrene, straws, and that's often in an effort to prevent litter as well as to prevent contamination in the recycling. So zoning and planning, I think people don't always think about that when, thinking about waste management or recycling. It's really important, especially at that local level. If you ever try to site a facility, it's a very lengthy process. So how more difficult or easy it is to build or expand a facility really depends on that state and local government process. And if you don't have a recycling facility nearby, or even a landfill nearby, it gets very costly to start hauling materials long distances. And there's an environmental impact to long haul transportation as well. So thinking about how to site facilities. Okay, we just talked a bit about chemical recycling, so I won't go into that much, except to mention again, this is related to the zoning. State policies really have a role in how difficult or easy it is to develop chemical recycling. Is it zoned for it? What's the definition of it? Are there tax incentives? Things like that. Okay, we had a really good overview of the recycling process. I do want to just focus a minute again on sorting the materials. Tim talked about at the beginning what a MRF is. This is when you have all these different materials in your bin, it goes to the MRF and they get sorted. So without this, it can get really difficult to get good quality materials. Part of the challenge is that these are not everywhere. The Recycling Partnership has a really great map on their website that shows MRFs in the US. And you can see in that website, on that map, that many parts of the country just don't have very many MRFs. There's some states that maybe only have one. So again, that limits, if it becomes costly to get the materials to where they need to be sorted, you might just not offer recycling because it's too difficult to do that. MRFs have a really good range of technology. I'll show this video really quickly, or part of it. So this is a robotic sorting arm. So just, even in the last 5-10 years, there's been a lot of new technology in the MRFs, AI, optical sorters, robotic arms. It just continues to grow, that MRFs are installing this new technology. So that really helps get the contamination out and be able to sort different types of materials. This isn't cheap. There needs to be an understanding that if you're making investments in the MRF, you will have an end market for the product that you're sorting out, right? So that gets to the end market development. So that can come from voluntary action to, buy recycled, and it can also come from mandates to use recycled content. So we know the technology is there and there's expertise there. So sometimes it's, what's really the incentive to make these moves and make sure they pay off, because it is a business decision many times at the end of the day. And there was a question earlier about, how do you decide what materials are accepted at the MRF? Well, sometimes it just comes down to, is there technology there to accept it? Can the technology sort it? And maybe there's technology available that can do that, but then you need to make the investment to take care of that and buy it. Okay, quickly on global efforts, there is a lot going on. The United Nations Environmental Program has been negotiating this kind of international agreement over the last few years. It was meant to wrap up just this past November. However, it did not. So they're continuing negotiations into this year. And this is really looking at the full life cycle of plastic, from production through use. It's looking at the chemicals used, microplastics, how do we get plastics out of the waterways, all pretty much everything you could think of. So this has been a really cumbersome process, as you can imagine, and depending on where this ends up, it could really impact how plastic is handled at a global level. Some other interesting things to look at are the European Union is actually phasing out different types of single-use plastics, and is also working to have more requirements for recycled plastic content. I think there's a lot to learn from extended producer responsibility in Europe as well as Canada, where it's been in place for much longer. There's some best practices or lessons learned there. And interesting to look at, Canada is putting together a federal plastics registry to kind of track the life cycle of plastic there, and requirements around using recycled content as well. So lots going on globally to look at. And as we know, trade and tariffs play an important role, and that may be impacting us very soon. So thinking about that and where materials can go and how it's handled is important as well. So to conclude, just remembering that, policy is an important tool and it needs to work with all these other parts of the system, the collaboration and voluntary efforts and everything else. Recycling does work, as long as it has all the support it needs. And this is a really important part of the solution. Thank you.
Thank you so much, Kristyn. I am going to ask you a question first, but what I want to do is welcome all of our 4 speakers to join us for this question and answer discussion session of the rest of our time together. I want to remind the audience that they can continue to ask questions in the Slido, and you go to slido.com and enter hashtag plastic waste management. And I also want to let our audience know that you can upvote specific questions. So if you want to bring them to the top, vote them up so that we can ask the ones that have the most interest. Kristyn, I think this question is really geared towards you, but I think all speakers could answer this. We're curious if any particular state policies are helping to advance specific waste management solutions. If there are innovative policy or regulatory initiatives at that state or local level that's helping.
Yeah, it's a good question. I'm hesitant to point to a specific state, but I think we do know that looking especially at some of the West Coast states, Washington, Oregon have higher recycling rates, California, because for many years they've really been pushing recycling, and in some cases there's requirements to recycle, there's incentives to do so, and the investment is there as well, right? Recycling is provided. SWANA released a report just last year about the city of Seattle and the programs it's had in place for decades. So I think looking at some of that is informative. Because it is policy, it also comes down to culture and, if everyone's recycling, you're more likely to do it as well. So yeah, I think certainly there are states we can look at to inform that, but I don't think there's ever kind of a magic solution. I don't think it's one size fits all. Even within one state or one city, it really varies how material is managed. And Tim touched on this a little bit, but it is a mix of public and private sector, right? Like the municipality is kind of ultimately responsible for making sure material is collected. But it's then up to them to decide, are they contracting out services? Are they handling it themselves? So you kind of really need to look at what's the current system in order to determine the policy. So I don't think you can take a policy from one state and just apply it to another. You really need to consider what's the current landscaping look like.
Do any of the other speakers have an interest in addressing that question?
Yeah, I think maybe just add on what Kristyn said, right? So bottle deposits are proven to increase collection rates. So if you look at Oregon, they have a 10-cent bottle beverage deposit, and they collect over 90% of their PET bottles and beverage bottles compared to an average of 25 to 30% in the other US. There are drawbacks to that, right? So if you pull the PET bottles out of the MRF, they lose one of their more profitable streams, so it makes recycling everything else a bit more expensive. But it has been shown to increase collection at least.
I can't speak to specific states, but one of my colleagues has done some work on figuring out how much collection rates could increase based on different interventions. So just increasing access to recycling programs was the number one. A lot of people still don't have access to a recycling bin. Second one, as Scott mentioned, was bottle bills, but then also education programs and cart tagging, where someone goes around and says if you did a good job on your bin or not. I feel like Tim would be a good person to do that. So yeah, those are a few kind of interventions that seemed like they could be successful.
I can just add that, there are cart tagging programs that are being tried out here in Florida. But the idea of at what level can you influence beyond just education, what people put in the bin is a pretty big challenge. And there are not many examples, but there are places where there are now requirements that you can't put a certain amount of recyclables in your garbage and vice versa. And so, as you can imagine, that's probably something that would be palatable in some parts of the country and not palatable in other parts of the country. So that, you know, in the bottle bills, I mean, those are the most dramatic examples.
Great. Thank you guys so much for weighing in on that one. I'm going to bring it to a very high level question. What criteria are used to determine which plastic cannot be recycled? Is that criteria consistent across the US? And what are some of the actions that can be taken to bridge the knowledge gap in the recycling criteria?
If I'll start real high level, real high level, but from a local government's perspective, they want to pull things out that they can sell normally, that they have a market for, that they don't have to throw away, even if they're not selling it per se. I mean, our community collects glass and pays $20, $30 a ton to get rid of it because they decided they've wanted to do that. But kind of in terms of what's recyclable, everything's recyclable. You know, if you put enough time and energy into it, you can figure out a process to recycle everything. But I think from a local government perspective, it's what do they have a reasonable chance of having the ability to find a market for it.
Yeah, I'll add on to that. I think it's just a lot of the components we talked about. Is there an end market? Is there a consistent end market? And is the technology there to actually sort out that material? So I think plastic film is a good example of this. You know, putting plastic bags in the recycling is not allowed in most places because of the machinery at the MRF that is used to sort the recycling. Those plastic bags actually jam the machinery. Now, other MRFs might have different types of machinery and they can accept that material. A plastic bag is recyclable, and in many cases, if they're, you know, separately collected, a lot of times your grocery store will take them back, but that's because they're separately collected, so you don't have that problem at the MRF. And those, you know, plastic bags can go to create park benches and decking and all types of things. So it is recyclable. It's just, you know, in what way is it recyclable? So yeah, I think there's a lot of factors that go into that. And so some of it, again, is the collection, the sorting, is there an end market?
And maybe just to tag onto that, you know, recyclable is a difficult word to define, right? It's kind of like sustainable, right? How do you define something that is multifaceted? So yes, I think you said people were surprised that number 5s are recyclable. They are, but if your local system doesn't accept them, then they're not, right? Not where you live. So there are so many pinch points in the system, making kind of broader degree or comments like polypropylene is recyclable, number 5 is recyclable everywhere. Well, yes, it's technically recyclable. It's mechanically recycled at, you know, several 100 million pounds a year, but if your municipality doesn't collect it or doesn't sort it, then it's going to the landfill wherever you live.
I don't have much more to add beyond all these great points, but I was having a conversation on this topic with a colleague recently, and she was saying, should we be thinking about the term resupplyable rather than recyclable? Because as a couple people have said, technically, pretty much all of our materials are recyclable, but what can actually be resupplied to the market based on market demand as well as technical capabilities is a bit of a different question.
Thank you so much. I think a lot of the questions are getting at all the challenges, and the next lineup of questions has to do with mixed packaging materials. I'm going to kind of lump two things together into one question. So there's multi-layer composites, and then there's also packaging that has a label that is a different polymer, say, than the bottle itself, than the plastic cap. What happens to products when with mixed packaging materials that aren't separated? Where do they go?
I guess I could start on that one. So let's start on the other side. So say we have like a cleaner that's in a PET bottle with a full label, right? And then it has a spray dispenser on top of that. So there are ways to design that label to make sure that that bottle goes into the PET stream. And our design guidance kind of spells out how to do that. So then once it's in the right bale, the PET bale, when it gets to the reclaimer, we walk through very quickly many of the processes that they go through. They will grind up that bottle with the sprayer on top, and then they will separate the ground material from the sprayer from the bottle via just density in a sink float tank. The sprayer will go to most likely durable goods, pipes, storage containers, automotive, and then that bottle will go back into bottles or textiles or something like that. So for things like that, they can be designed in such a way that they are mechanically separated in an automated way. For multi-layer packaging, and there's a couple of different ways to split that up, right? So there's multi-layer and there's multi-material. So a package might have 6, 7, 10, 13 different layers, but it might be different layers of the same type of plastic, but different variations of it for whatever purpose. Or it could be multi-material, like a chip bag that's polypropylene and a print layer and then aluminum on the inside. So the aluminized materials are much more difficult to recycle, and that's kind of a poorly defined term too, right? But it's difficult to separate that aluminum from the plastic. The multi-material or multi-layers that are the same materials, those can be ground up and recycled together in the plastic and in a single process and go back into like plastic lumber or even back into film if, again, they're properly designed. I mean, at the end of the day, I think as we look at APR and how we design it, we are designing packages so that the consumer doesn't have to worry about the construction, right? They just have to look at the bottom and see if that number matches what their municipality accepts, or the description, if your municipality uses yogurt containers and butter containers and jars and that sort of thing.
Wonderful. Thank you, Scott, for that. There is a follow-on question, especially about multi-layer packaging. Is there anything being done to innovate packaging designed for recycling? Or is there any new recycling technology developments for that multi-layer packaging? Sort of on the front end and the back end. Are there innovations happening for that?
So in the design space, yes, there are new barrier materials, there are compatibilizers and tie layers that allow for multi-material, multi-layer packaging to be recycled. On the back end, yes, chemical recycling is emerging, and some of those processes can take some of these more complex materials. Right now, I think if you look at volumes of chemical recycling in Europe, I think something like 2% of the recycled process polymers or plastics come from chemical processes. In the US, we're probably in that 2 to 5%, with the caveat that 2 of the largest chemical recycling plants in the world are currently scaling, with Eastman's plant in Tennessee, which I think they spoke about in one of the first webinars, at 250 million pounds a year, and then Pure Cycle's polypropylene recycling facility at 110 million pounds a year in Ohio. So I think there are innovations on both the front end and the back end that will enable that. The complexity is, again, in the collection systems that require somebody to take something back to the store versus putting it in their curbside bin. And there are technologies, and maybe Kristyn can talk about it, right, at the MRF level, or Tim, that enable the separation of those flexible packaging, but it requires a significant investment. And right now, I don't think the economics support that.
I can add on to the kind of the chemical recycling space. As Scott mentioned, right now, still early days, very little plastic is actually chemically recycled, but there's a ton of ongoing research to develop better, more efficient chemical recycling options and start to scale these innovations. And some of these are able to tolerate contamination up to like 30%. So that's when you can start to think about some of these really mixed streams could be feasible to recycle by chemical means. And yeah, a lot of ongoing work at NREL and other places in this space.
Thank you for discussing that one. Taylor, you addressed the carbon dioxide impacts of recycling and other solid waste management techniques. What are some of the other environmental and human health impacts to solid waste management options?
Honestly, there's so many things we could talk about if we wanted to. I'll maybe just touch on a couple with specific focus on human health. So things you can think about are toxicity, particulate matter formation. So toxicity is kind of, as we're emitting chemicals, how do those interact with our body? Particulate matter formation, as I mentioned, is if you're forming small particles that we then breathe, it can cause respiratory problems. So when we think about these different end-of-life options, how their impacts are will vary. Incineration, for example, will have higher particulate matter formation than many of the other technologies. Landfilling will in general have a higher non-carcinogenic toxicity. And this is usually not related to the plastics itself. It's related to all of the stuff that's mixed into municipal solid waste and ends up in a landfill. And then for recycling, you're going to have a bit of each of these emissions, but in general, they tend to be lower than what you would get from manufacturing these plastics from fossil fuels in the first place. So that's kind of a brief overview, but happy to go into more detail if needed.
Thank you. Yeah, I know the LCAs spit out all those other impacts, but we often speak about the global warming potential because it's sort of the first in front. Thank you for that answer. So this is a question possibly for Tim. Please comment on the methodology for calculating recycling rates. We have a note here that older EPA guidance assumed that 100% of materials shipped from a reporting jurisdiction to be recycled elsewhere are actually recycled. That was the assumption. Has EPA updated this methodology?
Well, so backing up, that the stuff I showed you was the kind of the tried and true approach that EPA uses called a materials flow analysis, where what they do is they actually gather production statistics and they have consultants who are able to track, for example, every type of resin and different kind of products. And then based on whether that is something that is going to be discarded over a certain period of time, they use the kind of the lifespan of that to determine how much is there. And then they go out and they just gather, industry, government data to be able to come up with estimates of recycling rates. And again, in a lot of cases, depending on how that's reported, that might simply be the recycling rate associated with it was pulled out at a recycling facility and sent somewhere to be recycled, as opposed to necessarily always going into a market. I think another challenge, I think others have hinted on this, is that measuring recycling and measuring waste is pretty challenging. And if you go and you get data like at the state level, it could be completely different than what you might see at the national level. And one of the challenges we have is sometimes places we just don't really have very good data. Now, I don't know, Scott may have access to more kinds of data from the actual processors and things like that. kind of at the state and local level, we're all at the whim of the recyclers and the local governments and the data that they report, or at the federal level, we're kind of at the whim of, you know, a few consultants who have really detailed sources of data that they put together. I can't speak to whether EPA has changed or done it better or not. I just know that anyone who deals with waste and amounts and rates kind of knows that you got to take those numbers a little bit with a grain of salt. So you got to be careful.
I would add to that, I think there's a wide recognition that there's a lot of work to be done with data collection. Every state kind of has its own way of recycling rate, how they define it and how they calculate it, how they get the information for it. So it's also fairly difficult to compare state by state what the recycling rate is. There's been some independent types of reports on this, but if you just look at like a state agency report and their recycling rate, it does vary quite a bit. And I just know from experience, sometimes it's voluntary reporting. So it's basically the state agency, you know, asking local governments to report their recycling, and then the local governments asking, you know, the businesses and institutions within their jurisdiction, how much are you recycling? And if they're not required to report, there's just a lot of data you're not even getting. So yeah, it's definitely a gap. The EPA did release a report fairly recently about, it's kind of like an infrastructure needs assessment, and it's also putting together information on the state data collection. So that kind of like surveyed states on, you know, how much do they track and how much do they report and what kind of data is collected, and it just showed there were some big gaps as well. So that's called the Recycling Infrastructure Assessment and State Data Collection Report. So yeah, I think there is a big need. There's been, you know, efforts over the years to try to standardize data collection and improve upon it, but we have a long way to go there.
Wonderful. Scott, did you have anything to add? I saw you're off mute.
Oh, yeah, I think so. The numbers I shared are done through surveys to recyclers, so they kind of know how much they buy and they know their capacity and their throughput, right? So that's kind of, it's one way to go about it, but it's incomplete because not everybody returns the surveys, right? So so yeah, it's a difficult number to come to, and we all see the EPA's number or percentage, right? That 9% of plastics are recycled. Well, that's 9% of all plastics that are produced. So the polypropylene that goes into a yogurt tub that I can put in my recycling bin is counted the same as the polypropylene that is in my car bumper, which doesn't go into my recycle bin, right? And most likely will get landfilled. Hopefully won't get landfilled at the end of life, but currently they get landfilled at the end of life. And we need to ensure that when we report numbers like that, that we report reality-based numbers based on what is actually recyclable, not what is produced.
I do want to add on to that. Scott made a good point there. So we've principally been talking about what we call municipal solid waste residential. So again, that EPA and state reports are often looking at that residential recycling. So that's only like a little piece of the picture. There's so much, you know, kind of bigger institutional industrial plastic, you know, agricultural, if you think about agricultural plastic film, healthcare, textiles, there's so many other sources of plastics that probably really are not getting tracked in many of these data reports. So it's important to keep that in mind as well.
Yeah, I was wondering about the textile industry. And if textiles are included in these numbers or not at this point. Seeing head shake, no.
No, they're not included in the PET recycling numbers. And if they were to be honest, they'd be probably a rounding error at this point.
They would be around what?
A rounding error.
Okay.
Although again, it's an interesting space, and there is a lot of technology being developed in that. If we all think that a multi-layer package is a complex construction to recycle, textiles are so much more beyond that, right? Because you have buttons that you have to remove, right? Or zippers and snaps, as well as the filler, the loadings of colorants and pigments are much higher. So, you know, the chemical recycling yields of a PET bottle compared to a polyester leisure suit, let's say, the bottle will give you a much higher yield than the leisure suit just because of all the other components. I know, and Taylor can probably talk about it, there is a ton of fantastic work at NREL going on in textile recycling right now.
Yeah, textile is a big area of focus, just because, as Scott said, right now, very, very low rates for dealing with textiles. And there's really a number of challenges that need to be addressed. The first is the collection. This isn't stuff that is going to go to your MRF. It's going to have to go to a separate drop-off point. Diversity. So we're not even just talking clothing, which has many different types of plastics, nylons, polyesters, etc., but also things like carpets, that's a textile. And so there's a lot of ongoing work figuring out how you could chemically recycle some of these textiles back into the raw materials so that you could produce textiles again. I know there's also work in the mechanical recycling space. I remember I went to a presentation recently that was focused on mechanical recycling of textiles and figuring out how to remove zippers and stuff like that so that you could be more effective in your process. So definitely a big space for innovation.
Thank you for that. So Scott, there was something that an audience member noted in your slide where you had the 4 different columns. You had the amount of recyclables being collected, the amount that the reclaimers in North America were processing, and that's a big drop. What are the reasons for the amount that we're collecting not making it to the reclaimers?
I might have not done a very good job of presenting that slide. So if you look at PET containers, 97% of what is collected in North America gets recycled in North America. I think the other numbers that I showed was the capacity of the reclaimers. So, you know, for instance, I think if we stick on PET, our data shows that 867,000 tons were collected. 97% of that was recycled in the US or in North America, excuse me. But the capacity to recycle PET is 1.3 million metric tons. So there's excess capacity that's not being run at, you know, full volume or is in the process or is waiting for more collection. So,
Gotcha. I might have been mistaken. I think that second column are the units on that percentage?
yes.
Ah, that's where I failed to understand. Okay. What could we do to increase the amount going to the reclaimers?
Collect more. I mean, that's what can increase the amount going to reclaimers is we need to put more in our recycling bins. We need to have equitable access to recycling as people have to garbage, right? So everyone should have equal access to recycling as they have garbage. We need to simplify the system. Tim talked about different recycling systems in different municipalities around Florida. Where I am in South Carolina, there's 2.2 million people and at least 26 different recycling systems or recycling programs. And the majority of them feed the same MRF. So whereas everyone has different requirements or restrictions as to what they can recycle, they're all going to the same sortation facility. And part of it, as Tim mentioned, and I'll let him talk to it, or also Kristyn, is it's what the municipality has negotiated with their constituents and with the sorting facility as to what gets taken.
I was just going to add that, Jennifer, that's the big question that we have to figure out, because that we, in Florida, again, not to stick everything back there, but there over the past 3 or 4 years, there have been a number of local governments who have stopped collecting recyclables. And so it's not a matter here about trying to figure out how we can add more or find more markets. It's like Scott's saying, they can't get enough PET in Florida. Yet at the same time, there are local governments who say it's not worth the effort. So I'm not, that's perhaps more of a sociology question than a scientific question, but at some point it's about trying to how do you embrace and how do you educate and how do you get politicians, the public, the decision makers to better understand what the benefits are. You know, we can do this life cycle assessment and get the data, but we just have to communicate, and sometimes that's just a big challenge that I think all of us need to think more about how to do.
PET specifically, the U.S. is a net importer of PET bales. So we buy recycled bales from other countries because we don't collect enough ourselves to feed the demand.
Boy, that's a statistic that educates for sure. That's really fascinating. All right. Well, I'll move on to the next question. Are there any policies to help increase reuse across the country?
I will start on that, I guess. So reuse is a really important component, and at this point, I've heard of a lot of reuse pilots. So policies, I think this sometimes is where EPR comes in. There's something called eco-modulation, where you're basically providing incentives for kind of how the product is designed. Minnesota, for example, has reuse kind of within its EPR legislation. So yes, there are some examples of how policy can play a role there. And I think, again, thinking about what's your forum for reuse. So a lot of times in a, forget the exact term, but it's kind of like a closed environment where you're not leaving. So think like a concert venue or a stadium. There's a lot of potential for reuse because you're, you know, if you buy a, you know, beverage, you're consuming it there, you're leaving the cup there. So great potential for reuse of cups there. Reuse in like more of a commercial setting, like grocery stores and things like that. We're seeing, I think, more right now voluntary. A lot of brands are experimenting with reuse models. Some brands are, their whole model is reuse. Others are, you know, established brands that are experimenting with, you know, reuse lines where you go get your container refilled, or you know, ship it and it gets refilled and it comes back to you. So there's really, I think, a lot of interesting things going on there. And like that would be a whole, we could have a whole webinar or series of webinars on reuse. It's a really big and growing topic. I know, and there's organizations out there that really are focused on reuse and doing more with it. So for policy perspective, I don't have like a specific one in mind. I think, you know, maybe Minnesota would be interesting to look at. And then again, I think at the state and local level, in California as well. There's some examples to look at, yeah, but I don't know of like a kind of like specific model reuse policy in mind, but I'm glad somebody brought up reuse because it is really important.
I think beyond reuse, there's a lot of other circular economy strategies we can think about, right? Like repairing, refurbishing, extending lifetime. So like the EU has this directive on right to repair. So the whole idea is hopefully that you'll be able to more easily fix products and keep them in use rather than throwing it away and getting a new one. So that's another area that people are looking at.
And Tyler, you would know more about this, but I know the LCA really fits in here as well, because if you think about reuse, if you're, I don't know, sending a reusable container a long distance to get it refilled, there's an impact there. So it's not, I don't know, thinking about like the LCA and like where materials are going and where they're coming from is important as well. But yeah, reuse of materials, right to repair. You know, we didn't talk about like plastic coming from electronics, but that's a whole other aspect. You know, how do we just keep materials in circulation for longer? As we looked at it that in the butterfly diagram that I showed at the beginning.
Kristyn, you nailed the next question. It's right here. It's how have LCAs been adapted for circularity, materials that have multiple lives?
That's a great question, and it's still definitely an ongoing research topic. We're trying to figure out the best ways to really figure out the impacts of these products over multiple lifetimes. Some things that have come up. So first, you can start to kind of figure out how many lifetimes a product could have and then normalize your impacts across that number of lifetimes. That's one way you can do it. You can also think about kind of a not necessarily a weight-based unit, but rather a time-based unit or a function-based unit. So perhaps you're looking at the impacts for a year of drinking water, for example, and that could help you capture the impacts of using a disposable bottle, purchasing a whole bunch of those versus, having like a reusable one, and using that over and over again. So there's a bunch of different ways people are looking at it. Unfortunately, there's not a harmonized approach yet. I would love to see that happen at some point and maybe get integrated into some of those ISO standards. But yeah, definitely something we're trying to nail down.
Thank you. The next question takes us outside of the US. Are there any regulatory policy examples from other countries worth highlighting for their potential to improve waste management?
Yes.
Yeah.
Right?
Tell us about it, Tim.
Yeah, no, I'm sure others are better experts, but I mean, if you look at what's gone, in like I was in Korea, about a couple months ago, and what you see in a lot of Asia is that just the way that you collect, it's really based on what we do in some part. You've heard of pay as you throw. It's the system in the United States, what we call that sometimes, where you pay by what you generate, as opposed to having, you put everything out on the curb, you shove everything into a can. And so they have systems, where you'll put your recyclables in a clear plastic bag, and that gets picked up for free. But if you throwing away garbage, then you don't. And you pass some neighborhoods and they have closed circuit cameras that are watching to make sure people aren't out there doing and putting the wrong thing in the wrong bin. And I'm sure someone probably knows better, but the packaging directive in Europe, in terms of making the folks who manufacture the packaging and the products beyond that responsible, and then providing the funding to provide the recycling infrastructure, which is just something different than we have here. But I'll let the others jump on.
Has anyone else seen international solutions?
I mean, I think few of us mentioned extended producer responsibilities for packaging, and extended producer responsibility isn't something new for the US, right? We all pay, what is it, $20 or $25 when you get a new car battery to ensure that those batteries get recycled, and they have a 95% collection rate. Europe has been doing extended producer responsibilities for packaging for years. Some do it better than others. Our friends just to the north of us in Canada, right? Each of the provinces have their own EPR. Maybe not all of them. There's a couple that don't, but have EPR policies where they, and for those that aren't familiar, essentially it's a charge that's put on a specific package that is, in theory, there to offset the cost of recycling it. So a package that is more expensive to recycle has a higher cost to the manufacturer versus something that's easier to recycle, and that funds infrastructure to collect. I think Europe also has minimum recycled content laws that they've had for years. We're starting to get those in North America, California, New Jersey, Oregon. I think Colorado is going to have some of those, maybe even Maine, and I'm not sure about the Minnesota bill or not. So I think we're seeing some of the policies from Europe specifically come into the States. The pay as you throw, I think that's probably a tough sell in the US, but maybe that's part of the solution that we get to. And as we think about flexible packaging and having those taken to the stores, right? In Europe, flexible packaging is collected mostly at the homes. And the reason they can do that a little more easily is they separate out paper and cardboard from plastic packaging. And when you separate out paper and cardboard, it makes it way easier to sort the flexible packaging. So some of these new collection systems, I think we will eventually see, but we've moved from multiple streams to single streams for efficiency and for participation. So the amount of stuff in the recycling bin goes up if you have a single, in general, a single large bin versus two smaller bins. But then contamination goes up too, which isn't great.
Well, as we are concluding our time together, we only have 5 minutes left. I want to open it up for any of the speakers to give any final thoughts on plastic waste management solutions. Anything we didn't cover today that you're like, wow, we need to say this.
Maybe that it's only plastic waste if it doesn't get back into the recycle stream. If it gets back into the recycle stream, then it's a new feedstock, right? And you're making new products, you're making new materials out of that. So, continuing maybe to use the waste nomenclature kind of gives everyone the idea that there's no value to it, right? And the only time there's no value to it is when it's not in the recycle bin.
I would just echo again, sorry to repeat, but there's a real challenge right now in many parts of the US about even keeping recycling all together. And so I think that being aware that that is out there and trying to better communicate the value, which is not always dollars and cents. Local governments pay to have recycling programs, and we need to better demonstrate and educate why there's a benefit to paying for that.
Yeah, and that, I mean, recycling is about supply chain, right? So you don't have to depend on fossil fuels, you don't have to depend on natural resources, you don't have to depend on those imports from other countries that, might become unaffordable or get cut off. So recycling is supply chain. It's, how do we get the resources we need to make new products and new packaging? So it is important. So yeah, I think to Tim's point, kind of doing more to share the value of recycling. And, recognizing this is focused on plastic, but plastic gets collected with other materials. So I focused a lot on recycling in general, and, it's kind of what it takes. How do we invest more in resource management overall in the collections, the communications, the infrastructure, and make sure those end markets are there, and that will make it more sustainable into the future. And I guess when I say sustainable, it's environmental sustainability, but it's also just self-sustaining, right? If your supply and demand are there, ideally it all connects and you have demand, so there's supply. And sometimes policies are just needed to, get those things to connect because it is a complicated system.
I think something that I hear a lot is that plastic recycling is a hoax. And I asked my colleagues if they agreed with that statement, and actually more than half of them said that they thought that was true. But when I went to a 5th grade school classroom and asked them the same question, well over half of them thought that that was false. So I think we need to keep hope and remember that recycling does work as long as we get the material into the system. And it is a benefit to all of us to think in that way.
Thank you so much to all of our panelists for your very thoughtful perspectives on this issue. We extend our gratitude to the audience and broader community for their engagement today. The next webinar in the series will be in March on plastic pollution, where we will touch on a lot of the questions that came through about micro and nanoplastics. To register for that event, watch the event recordings and stay up to date on the activities of the Roundtable on Plastics. Please navigate to our Roundtable website. Caroline, would you like to say anything?
Sure. Thank you so much, Jennifer, for moderating this webinar. And thank you again to all of our speakers who joined us today and the audience for the questions. I do also want to give a little bit of a plug for some of the more health-related questions. There is a separate group at the National Academies. The Environmental Health Matters Initiative has a series that's coming up on more on the plastics related to human health. So that was why we've kind of steered away from some of the health related questions. So please check out, we'll share information for that group as well. But thank you again and have a wonderful Friday afternoon.